Today we are going to talk about the coke properties for the blast furnace. Coke property is a wide topic. Today our talk will limited to CSR and CRI of coke. As we can see in this slide, CSR and CRI are interdependent uh, mm, properties of coke, and for a particular CSR, CRI can check by operators in case of any mismatch. This slide also gives information to blast furnace operator to check for a particular CSR what should be the CRI level, and also to check the any process upset of the furnaces where CRI deviation intensity can be measured in terms of CSR deviation. So if we have a some deviation in CRI, we can for example we can take a CRI gone up by some 3-4 points. So in case CRI gone up by 3-4 points, definitely CSR will come down, and this will affect the furnace because load bearing capacity of the blast furnace will come down due to this deviation in integrity of coke structure. So this can gives some information to the operator in case of there is change in CRI value. And this is all about a explanation to blast furnace operator that how the things happens when a CRI gone up or comes down, how the CSR gets affected and why. Now this is the area where I want to focus more because the variation of CRI depend on many factors, and few factors of them is also essential to known to the blast furnace team. And two very important aspects that I want to discuss in this slide is alkali and sulfur in particular. Alkali is a really killer, and it exponentially increase the reactivity index and make the coke very weaker. Similarly, sulfur is also helps in making a reactive coke. Thus, these two parameters must taken into consideration while diagonizing any process upset in the blast furnace. Now, the basicity part is also having a tremendous role because these also helps in lowering or increasing reactivity of coke. The basic ash are basically result into low reactivity of coke, and acid oriented coal ash leads to a high reactivity. Porosity do have a contribution in increasing or affecting CRI. More porous coke has a larger surface area exposed to CO2, and due to this gasification becomes much easier, which leads to higher CRI. In similar to other factors, the carbon structure also dominate a lot in varying CRI level of coke. Like, for example, amorphous carbons are very sensitive, and they always result into a higher CRI value of coke compared to the crystalline structure, which have got a lesser contribution on increasing CRI value of the coke. Temperature and time of carbonation always becomes a most important activity for obtaining coke properties. However, higher cooking temperature and longer times always result in a better CRI, optimum CRI, uh, by the and blast furnace operators here are more comfortable with coke manufactured in such environment compared to the deviation like a lesser cooking temperature and shorter time. This sort of environment result in a coke having got a higher CRI and which create more upset in the blast furnace. Raw material sourcing always contribute in obtaining the right blend for coke manufacturing. And in order to exemplify, we can see the Australian coal, especially uh, they result into a balanced CRA value, whereas the Ukrainian or Russian coals are very highly reactive, and this result the ill coke with such type of coals like Ukrainian and Russian result in a higher reactivity. But ultimately, the whole epicenter lies at alkali content, and alkali content is one of the most sensitive factor which regulate the reactivity of coke. Thank you.